சொல்லு வாங்குச்சுன்னா அதுக்கு 260, அது பேர்ல வாங்குச்சுன்னா 260 தருவாங்க. இப்ப எங்க வீட்டுக்காரர் வந்து எப்படின்னா நாங்க 2 பேரும் ஜாயிண்டா போட்டோம்.
மேடம், பிருந்தா மேம். Aranam, shall we begin?
Yes, sir, we can start.
Okay. So, very good morning all. Welcome to the third day of our placement awareness training by Alumni Connect series. Today we have two more reputed alumni of our department from 2011 batch, Mr. Rohit Kumar Singh, who is currently heading as a senior engineer in the power supply and traction division in Sistra MEA Consulting Private Limited, and Mr. Pratik Kumar, manager hybrid and energy storage systems, Sterling and Wilson. So on behalf of the university, department, faculty members, and our students, I once again warmly welcome them and hand over the stage to Mr. Rohit Kumar. Rohit, please.
Yeah, thank you very much, sir.
Thank you. Thank you for joining with us.
Yes, sir. Good morning to my sirs and professors and fellow students. I'm very happy to be here. First of all, I would like to thank my professors for giving me this opportunity. It is a very good thing that I am able to connect again with all my sirs. I still remember the day when I was doing project under Ratnam sir, and we used to have classes with Sridhar sir also. So it's very fresh, even after it's almost 10 years. It's more than 10 years, but very happy to be here. I would like to detail about myself. I am Rohit Kumar Singh, and I am currently working in Sistra MBA Consulting Private Limited, as sir has already told this. To say about this session, we would be going in a streamlined session. Like I would give some presentation about the system or metro system. Basically, we'll look into some videos, and we would I would describe in the theory part what is there, what is not there, not that much. And after that, I would like to emphasize on the connection between theoretical world and the practical world, which we are basically related to, and how what we can do in our college time that would help us in going out in the industrial world and practice our theoretical subjects and everything. So I would like to start the presentation. I will share my screen, sir.
Yeah, permission given. It's visible.
Yes, yes. Okay. I would.
Full screen. Yeah, good. Super. Everything is proper, Rohit.
Okay.
Audio also fine.
So this is today we are going to start with our presentation, and this is to tell you about my company, Sistra. This is basically a French company. French company in the sense that the headquarters is in France, and we are having our India office. There are many offices we are having all over the world. We are having in Brazil, Hong Kong, UK, Australia, and India also, and Gulf countries also like UAE and Saudi Arabia. So basically, India is second largest office after France. We are handling from here all kinds of projects. And to tell you about my company basically deals with the consulting job, technical consulting job for the mass rapid transport system. Mass rapid transport systems is basically nothing but the metro systems all over the world. And my company was, the Sistra was first company, one of the first company in India to deal with the metro systems. They were the experts which were being brought in for starting the metro jobs in India. So basically from 2003, I would say from 1999 itself, from the basic concept of Delhi Metro when it was started, this company is here in India, and I'm very happy to be associated with them. So let's start here. I would not go into the details of those things. I'll just I'll touch briefly about everything, and after that we can have a discussion of how we can inculcate what we learn here basically, and in the world which I am working in, so that it would be helpful for all the students. Let me just be a little bit technical in the first. I know I would be boring many of them, but I would like to start with this point actually. We all know that we all travel by rail, we all travel by metro system. So basically, as an electrical student and as an electrical person, we would wonder that what kind of system are there in metro, even if metro or in railways. Although in railways there is basically AC traction system only. However, many of us who would have been gone to Bangalore or Kolkata, they would have seen that there is a difference between Delhi metro system and in there. So why it is that? Because there are two types of traction systems which we basically see in our systems. There are AC traction and DC traction. In AC traction, there are, like Indian Railways is having 25 kV system is there, 25 kV or 15 kV system will be there. And the most important thing, there will be overhead electrification. That means there will be mast or there will be a pantograph which is on the train and it will be connected to that. And there are DC traction. DC means there are these kind of voltage levels will be there, which are being used by third rail. I will not go in that detail. Just for understanding, you understand electrically, there is an AC system which is being utilized in Indian Railways, and it has to be on the mast and overhead. Over the train, there will be electrification work, and there will be DC electrification, which will be on these voltages, and this will be on the, there will be no mast for this. I will show you the photographs. If you see, the above two photos are of AC traction, which is with the mast, which we commonly see, which if we are traveling daily by metro or Indian Railways, we see this kind of thing. However, with third rail, there will be no overhead line. If you see this yellow line is there, that is third rail. In this only supply is being given. So many people argue in this aesthetics regarding the view. Many people say that this third rail beautifies the city. However, this overhead things looks very much hodgepodge and it is not good to slow. So there are basically many arguments. I will not go in that. If you see that there are use of DC traction and AC traction in India, if you see, you will see that there are these many metros. So many metros are there right now in our India, in which the biggest is the Delhi metro. They use AC traction. And if you see that these many metro systems, and here I have listed down that what are the systems being utilized. There is no hard and fast rule that why we go for AC traction or DC traction. That is the different thing to decide. However, if you see, Delhi metro is AC system, Mumbai metro is AC, Jaipur, Chennai, Lucknow, Hyderabad, and Nagpur. These all are AC system. In AC system, you will be able to recognize by the use of mast on the above grade line. At this moment, I would like to see one video. Actually, I would like to share a video. Yes, this is a video which is being made by Mumbai Metro. Let me know if it is visible.
Yeah, it's visible. Yeah.
Okay.
You're getting audio also.
Okay, sir. I would stop here a bit and I will tell everyone. If you will see that these are the kind of towers which we have, we call these things mast actually. And there are power supply being going on. So for electrical students, that is very important to know that these all the things are being designed by electrical people like us, and we are designing this. What we design is being presented here. It will be built what we design on paper. So it is very good to see when we are doing these kind of works, then we are very happy to see that it is being implemented in the real world. So showing the purpose of showing this video was to have an idea actually. I know people, we all travel by metro or somewhere down the line. Everyone in our currently whoever are there have been in the metros. And the most satisfying thing what I feel personally is after so many years in this industry, still we are very happy when we see that whatever we are doing as an electrical engineer is being implemented and is helping everyone in daily life. So being a part of it is a very satisfying journey for me right now. And to move ahead, I will not be that much technical because I know everyone will not be that much happy. But again, coming forward, I'll just let you know that what kind of works my company Sistra India, being a technical consultant, is doing. We are involved in feasibility study. Feasibility study in the sense that it is an initial study what we do. Like from the electrical and engineering point of view, if we are given a project like somewhere, some place a metro has to be started. So from an electrical point of view, we have to study that how much power, how much of electricity is being required, and what are the things, how will we distribute those systems, and everything from the scratch you have to start. That is as a feasibility study. Then the aspect when the system is being built, and like Delhi Metro or Bangalore Metro client is ready to be starting the works, then we do preliminary design and detailed design. Preliminary design in the sense that we do all the calculations. Like you would have now, if you are in 7th semester, I think, then you would have studied all those transmission, distribution, control, protection, earthing, and many things you would have studied that which really applies in the practical world in real actually. So here we go to the basics and we start from the scratch, we study, we prepare. So there are so many things which we can include here. So that is a part of design, and where we prepare everything that is being implemented. And one more aspect which we deal with is detailed project report actually. Detailed project report in the sense, what is the thing I will say, that one of the things is this slide is related to the detailed project report. Actually, when we prepare the detailed project report, we study that how much traffic is there in that area or how much is required. So that those are technicals, let's not go there. So basically the idea is that we do initial, when before starting any project, we have to provide project report, that whether it is feasible, whether these are the things, these many stations are going to come, these are the systems, these are the costing which we have to do. So not only technical part, we have to sometimes look into the commercial aspect of our job also. So it is a very mix, like best of both worlds, you can say, You do technical, you do commercial, and if you are interested, you can go into the commercial part also. So there are many fields which we do. So basically, these are the things which are being done in our company. And one more thing I would like to add that in preliminary design, we do simulation study. So in right now, I think you all will be aware with ETAP, I guess, because we have when we are in college, we used to do ETAP projects also. So basically, if you see that still after 10 years, I'm using ETAP with what we have learned in college or what our teachers have given us. So the idea of saying this is why, because ETAP is a software which we will use after many years also, and it is very satisfying to use that, because what we are learning in college, we think that okay, it will be applicable in future or not. But yeah, let me tell you, 10 years experience that whatever you are learning in college, the basics will be always with you. Maybe you will be doing something else in this regard, however, but the basics will be the same. So I would like to show one more video that is actually basically not electrical, but however, when I first started working in metro jobs, I was very much happy to see that animation actually. So I will just show this video.
When it opens in 2018, Crossrail will tunnel boring machines or 8 tunnel boring machines or TBMs will drive through the ground to create Crossrail's tunnels. A TBM is 148 meters long and weighs 1,000 tons. This is the equivalent of 14 London buses end to end and a staggering 143 buses in weight. It has a rotating cutter head at the front and a series of trailers behind housing all the mechanical and electrical equipment. There are 2 types of TBM being used by Crossrail: earth pressure balanced TBMs and mix shield TBMs. 6 earth pressure balanced machines will be used for the 18 kilometers of tunnel through the clay to the west and the riverbed deposits in the east, while 2 mixed shield machines will be used to drive the tunnels through the chalk beneath the River Thames. Depending on the geology below and the buildings above ground, each TBM will travel between 90 and 150 meters each week, ending up to within a millimeter of where it needs to be.
Sir, audio is there, na?
Yes,
sir.
yes.
Yes, sir.
Okay.
Yes.
The first part of the TBM's work is the tunneling phase. The earth pressure balanced TBM has a cutting wheel which is pressed against the tunnel face by hydraulic cylinders. Inside the cutting wheel, the disc cutters and scraping tool loosen the material. If the earth is unstable and to stop the tunnel face collapsing or digging too fast, the TBM uses the soil that has already been dug out by the cutting wheel to support the tunnel face. This creates a stable environment for the tunneling to move forward. The tunnel face is continuously monitored by pressure sensors. They check the turning power of the cutting wheel and the screw conveyor, and they also keep track of the material that's been excavated. The material is then taken away on conveyor belts. Once the tunneling phase is done, the cutting wheel and screw conveyor are stopped and the ring building phase starts. A complete tunnel ring consists of several lining segments made of pre-built reinforced concrete. These are made in a special factory above ground. They must match the exact size required and are taken into the tunnel on flatbed rail cars. The concrete segments are fed in by the segment feeder and lifted into place using a vacuum. The hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with millimeter precision and held in place by cylinders before being finally bolted into position. The conical keystone is put in from the front to complete the lining ring. Each individual tunnel ring is built in a slightly conical form. This means that curves can be built along the tunnel route by changing the direction of the cone. The hydraulic cylinders are extended again to secure the segment into position. During all this work, the people and machines are protected by the shield skin from the saturated ground where water is under pressure. All the readings are displayed on monitors in the central control cabin and fed back to the machine operator. Once each section of ring building is completed, the next tunneling phase can start. The mixed shield TBMs dig in a different way to the earth pressure balanced TBM and will be used for tunneling in waterlogged conditions such as below the Thames. Mixed shield TBMs use bentonite, which is a slurry of clay and water, to support the excavation face and act as a suspension medium for excavated material. The excavation chamber is behind the cutting wheel and separated by a submerged wall from the working chamber. The excavation is completely filled with bentonite and the working chamber is approximately 2/3 filled. The two chambers are connected in the form of communicating pipes via an opening in the submerged wall. A filter cake is created ahead of the cutting wheel by pressurizing the bentonite in the working chamber with compressed air. The bentonite penetrates the ground to form a membrane which holds back water. Changes in the soil can be handled by adjusting the pressurization. The dugout material falls into the excavation chamber. Small grains are dissolved into the bentonite and bigger stones and debris fall to the bottom. Flushing nozzles guarantee smooth removal of the excavated material. The excavated material is pumped through the suction line to the separation plane at the surface. Here, the soil is separated out and removed from the bentonite suspension through a centrifuge, and the clean suspension is transferred back into the slurry circuit. As tunneling advances, the flexible extension lines are installed to extend the lines after each thrust phase. Crossrail's first pair of TBMs, Phyllis and Ada, will construct Drive X, travelling from Royal Oak to Farringdon. A second pair of TBMs, Elizabeth and Victoria, will construct Drive Y, starting from Limo in Docklands and heading under central London to Farringdon. A further two TBMs, Mary and Sophia.
So I understand that this is not related to electrical aspect. However, it is very interesting to see that what are the things that is being employed in constructing the metro, and especially an underground metro. The one thing I would like to add here, being an electrical engineer, we think that we'll be dealing with electrical aspects only even after completing our degrees and going to work. But the most important thing what we learn here is working in a group as a team with various other aspects of engineering. Like we have to deal with civil engineering also. Over a period of time, we have to understand that what is civil engineering and what are the things that is related to them and how they will do interface with electrical, because civil, electrical and mechanical, these three aspects go hand in hand. If you are in a job, any job, like if you are doing any work related to electrical, be it any field, be it in power plants or be it in substations, be it in metro, be it in solar, anywhere if you go, there will be aspects you have to deal with these two other phases also. So over a period of time, you'll see that electrical, mechanical, civil, they complete each other. So if you see many a times in a college, we feel that what is civil and what is mechanical, but when we work, then we understand that yes, there are many aspects that has to be dealt with. So to move ahead with our presentation, and now I would like to discuss on the role of electrical and electronics in today's industry. I want to discuss this in detail actually, because when we were in college, we used to think that, okay, we are studying these every semester, we are having so many subjects, we are having so many lessons, classes, and what is the use? Basically, we used to think that, okay, this is just for attaining marks and coming out of college and getting a good job. The role of studies is not basically limited to those things. If you think that if you have studied in second year your electrical machines, your circuit networks, and then it will not be applicable in ahead. So there are aspects. Okay, theoretical part is not completely basically used outside. However, the basics remain the same, and the basics will be utilized. So it is very good thing to understand your basics and whatever you have learned to brush up your things, be it in industry world or you are preparing for competitive exams or MS. So what we study lives with us even after many years completing college. I have completed in 2011, but still when I work and when I do something, I go back to the books. We have to go to back to the books many a time. Some problems we have to look into the basics and again come up with a solution. So all the answers are in basics only. So let me touch up, like we used to study electrical machines and circuit networks there. So those are related to power supply system. We used to design here also. When we are working, we used to see those transformers. You have studied how to design a transformer, basically in theoretical part. But after that, when we are working here, we used to see that, well, yes, there are things which are being utilized there. Although I'm not in industry where transformer design or machine design is there. However, when it has to be there supplied by many people to the metro system, so we have to decide that what kind of system we need. So at that time, everything comes to mind, like what are the power rating of the transformer, impedance of the transformer, and all the technical things that we have learned. Sometimes it helps us, and it helps us in determining the system. One very good thing we used to study here is we study in our colleges that yes, this is a system, this is a one transmission line is going on, the one transformer is there will be one impedance, and there will be, we have to calculate the resistance or fault time VA or what is the system and how much power we need. So all these things, if we are understanding the basics, we have to apply this. We have to calculate that short circuit calculation. We still are doing that thing only. It's nothing something very difficult if we know the basics. Still we go like there is a how to calculate the short circuit. We have to go to the ETAP software. We will prepare the complete SLD, and we will do that kind of job. So it is very important to understand that the basics which we are learning here are very important, and they have a real world application. Although not that much of application in, I would say, that theory part, but the practical part is that we learn the basics there and we come up here. So these are few points I have highlighted, like power supply, SCADA, control protection, communications, and solar applications, and many more. So power supply, there in every semester we study many things related to this. Actually, this is a very broad subject, I would say. In earlier semesters, you would have gone through this electrical circuits. After that, you would have come to power supply and control, power systems and control, PSOC. And there was one more subject was there, control engineering. So these all are related to each other, basically. There is one more subject, transmission line, I think is there. I remember very correctly. In that, we used to do the calculations of transmission line, that these many lines are there, cable fault is there, and these many, if fault occurs, how to calculate that, what is the fault level. So all these we have studied, whatever we have studied is still applicable there. Yeah, I remember if we have studied this SCADA, I remember we have studied this is supervisory control and data acquisition is there. So this is basically a heart of any metro system. A heart in what means is that this system collects all the signals, like my transformer is working correct or not, my circuit breaker is working properly or not, if the current which is going in the system is as per the required value or not. So all these things will be collected and sent to a common center, actually. Common center, and there it will be fed in the system, and then it will be, the system will determine that whether there is a fault or not. So basically the idea is that the theory part which we have studied again there, it will come in hand. So my point of this lecture is like what we are studying will come in hand to hand with the future working also. If we are looking into the core sector, in any sector you go, be it metro systems or solar or transmission line or product design like transformer, generator, everything. The third aspect is very important actually in electrical field, and this is complete world in itself actually. control and protection. We have learned many kinds of protection device like differential is there, overcurrent, earth fault, all those things what we have learned now, we are still using it. And there is nothing what to say, very much complicated about those things. However, what we have studied, we are applying still. So if you are seeing the differential protection principle, one, this line, this side, one current transformer will be there, other side, one current transformer will be there. The difference will be every time in normal condition will be 0. And if the difference is not 0, then the system will take action if it is outside the a set value. So that's it. This is the concept of differential, and still that is being utilized here. The difference is that the application comes in real world, so there are many relays and all those things will be there, which is being included in here. So that you, over a period of time you'll understand and you'll come to know that okay, this. However, the basics remains the same. Why I'm saying control and protection is another word, because there are people, or there are many experts who have done only control and protection in their life. Like for 30 years, I met with people who are having 30 years, 40 years experience in only this control and protection, and still they consider that they are learning. They always say that whenever I met an expert, they still say that they are learning. So that is the very surprising thing for me to understand, that people are still learning. So don't worry that learning is being finished when you get your degree. It will be always with you. The next is communications. We are having our power electronics part 1 and part 2 in our college. So if you are looking for an electrical field, okay, these are the aspects. But if you are looking for out and out only electronics also, then there is very much good scope for us also. The best thing about this branch is that this gives us two options actually. If you are related, if you are inclined towards computers or communications or electronics, then you can branch out from here also. Or you are, if you are interested in basic electrical like power supply, SCADA, control protection, you can go from here also. So that is the beauty of electrical and electronics branch actually. And I feel very proud that I was there and I learned from our teachers. They gave us very good knowledge about all these things, not only about the theory part, the application, the basics, everything, labs, what we did, you will be doing your projects, then also you will learn many things. So if you want to be in communications, like in electronics sector of this industry, then also you will learn that the things which you have learned in your college will be applicable. The next point what I would like to say is solar application. Solar application is a very solar application in the sense my colleague Mr. Pratik will be dealing with this in detail. But my point of writing it here is not only related to power supply, but now we are in a condition that we have to look for new sources of power. And I think the solar is the foremost runner in this one. However, there are many other renewable sources which we are using, and those all are related to our studies. Be it solar, be it renewable, be it hydro, be it some other source of renewable energy, the concept will be the same. So that is there. I think there is one optional paper in which we learn about solar also, I remember. I think. So there also you will be there. So what I want to say that in each semester, whatever you have learned in first year, okay, first year is common for everything. We have to start with the basics and understand the basics. In second year, we are having networks, circuit theory, machines, that is there. In third year, I remember there are power systems were there, control engineering was there, machine design was there. So these are very important topics, especially power systems. Power systems is the basic of electrical. If you know the basic power system theories, you will not have any problem in anywhere in electrical. How big the system is, the big oil refineries, the big power plants, the big metro systems, they all, from electrical point of view, just the basic is there. I would again like to emphasize on the word basic. So my request to everyone will be there, be strong with your basics and you will not face any problem anywhere. And coming to then next year, I think PSOC was there. Then many other additional subjects are there, and new subjects were introduced when we were there. Like I did with my mentor in project. Me, myself and Pratik, who will be the next speaker. We were doing a project with Ratnam sir only, and it was artificial intelligence actually. That time in 2011 itself, our college has introduced this artificial intelligence, and we used to do the project there. We use a software simulation using MATLAB that time. So there are things which we learn there. And again, if I'm why I'm saying, see, 10 years back you used to learn about artificial intelligence, AI, and now if you see, the AI is a core industry. It is an upcoming running thing. So just I will like to say that what we study there is real applicable. So my next topic of discussion, just 2 minutes I will take, discussion of applicability of theoretical studies in practical world, a dilemma or a truth. Many a times we think that whether what we are studying will be applicable or not, it is going to be how we will be using this one. We will be stuck in our job. We will be doing only those kind of, many of us would be having elder brother or sister who would be saying that no, nothing is there. What we study is there. It is not being applicable sometimes. But yes, many a times it may be true. But the basics will be there. You have to deal with that. You have to deal with basics. When you are coming from a college to industry, I would say that there will be many things that will change. You have to manage yourself. You have to manage other people. You have to meet the deadlines. Apart from these aspects, these are 20 to 30% of your job. If I'm talking about my job, particularly in technical field, managing other people, other things are just 20 to 30%. Basically, more than 50% is my job is related to technical, and I do those things. So don't worry for that. Whatever you are learning there will be useful in the coming days of your working. If you are in the using, or you are going for higher studies also, then also these things will be there. So don't worry for that. Don't be in that dilemma that whether I'm studying these things, that these will be applicable or not. It will be 100% applicable. And from a 10-year-old experienced guy, I'm saying these things. So there will be some truth in that, I would say. So I have taken up all your time. I think I was informative as well as I was able to keep your attention to myself. So that's it from my end. If any questions are there, I would happy to take it. Thank you.
Thank you, Rohit.
But I hope I was
Yes.
connected.
No, very
everything.
useful, especially the videos and traction related, and how you connected that with the basic subjects and the elective subjects, what you have learned, and still people are learning those generation,
Yes,
transmission, distribution, power system analysis, PSOC, and that point is very correct. If they are mastery in the power systems, then definitely they can do anything in the electrical. Very nice. With the Q&A, we will take it at the end. Pratik,
okay.
you may please.
Yes, thanks, sir.
Yeah,
So
welcome.
I will also share my screen here, and just let me know if you got my screen.
Yeah. I think Rohit has to unshare.
My screen is visible now?
Yes. Audio also nice.
Okay. Yeah. So thanks, Ratnam sir, and thanks the department for hosting us for the session. I feel that this session is really helpful to all the students of 7th semester, and probably we can come here and discuss our experience, 10 year of experience I'm having in completely in renewable business. So I feel that this session is really helpful for the students who is going to opt a core industry, and we can come up here and discuss what they're going to do. Since this is very basic questions in my in the freshers mind, that what we are going to do in industries. And coming to the whether they're going for the sales, or they're going for the construction industry, or they're going in a developer company, or they're going for a consultancy company, like Rohit is doing in consultancy firm. And probably our seniors has already have one sessions yesterday, right, sir, where they have discussed about the manufacturing companies. So I feel that this session will really we can guide them on what they're going to do. Just to begin with, I will just take you all through the power generations. Since I'm completely from the renewable business, I will explain more in detail about the renewable sectors. What are the potentials in the solar and energy storage markets? What is hybrid and energy storage business? And top renewable players where you can opt and what will be your role and responsibility in a EPC company. So before that, I will just give you my background. I passed out in 2011. I'm same batch of Rohit Singh. Even as Rohit told, we done even projects under Ratnam sir. Me and Rohit both the same projects, a neural network based project there. And in after 2011, after our graduation, I joined L&T Construction. I was there for 7 years, and in 7 years I've gone. We have been a part of many projects. Some of the few projects I would like to tell that I was a part of a Charanka solar park that was in 2011. It was Asia's largest solar park that time. I have done a 100 kilowatt small system in Tirupati, and I was a part of a Hyderabad Metro solar concept. Where probably if you guys have traveled to Hyderabad Metro, you might have seen that all the Hyderabad stations and depot are going to be solarized. So I was a part of that project as well, where this Hyderabad Metro we're planning to put the solar project. So I was a part of that one. I was also a coordinator of ultra mega solar park in Rewa, MP. You might have recently got the news that Narendra Modi has inaugurated the Rewa project. So I was a part of that project as well, and then I have coordinated many projects and solar projects in L&T. And from there, I moved to Sterling and Wilson, and currently I'm in a hybrid and energy storage business. I looks after the tendering and proposal for Africa, Middle East, Asia, Southeast Asia, and Australia. So Sterling Wilson basically deals globally all the power renewable projects. So come to the presentation here. So I was quickly discuss about the power generation capacity, renewable contribution, and the solar potential in India. So coming to this, what is the power generation capacity? If you might have gone through the report of CEA, you you can come across that the total installed capacity in India is 375 gigawatt. Out of that, major is from the thermal 231 megawatt and hydro 45 megawatt and 92 megawatt around by the renewable energy sources. However, if you have noticed that last 4-5 years, the maximum addition is from the renewable energy sources. So the renewable energy will be going to be a new is a big market. By 2050, India is going to be a net carbon zero targeting for the net zero carbon emissions. So renewable energy will be the very big market. Either it will be a solar, wind, or a battery energy storage altogether. Coming to the renewable energy mix details, if you see, we have a solar additions of 34 gigawatt till December 2020, wind of 38 gigawatt, and other renewable sources like biomass, thermal, we have 15 gigawatt. However, if you have noticed that last 4-5 years, the more penetration is from the solar. So solar is more preferred compared to the other sources. Wind is also a very big potential in India, but wind is highly unpredictable. So most of the firm is more focused on the solar projects. And yes, I will discuss more about the hybrid as well, because this makes the system viable. Completely solar and wind and battery energy storage, mixing all these three sources, make the system viable. However, as present, in the current scenario, the solar is going to lead the market. If you see the year-on-year addition in the renewable energy compared to the other sources, we have more from the solar energy. If you see the total installed capacity till today is 34 gigawatt and 46 gigawatt is in pipeline. India is blessed with the 300 sunny days, so we have a huge potential in India. As per the survey of Ministry of New and Renewable Energy, India can install 748 gigawatt of renewable power using just 3% of the wasteland. Means you might be aware that solar cannot be put on a farmland or agricultural land or very commercial lands. It can be only put on a wasteland. So India has only India can utilize even if 3% of the wasteland, we can install 748 gigawatt. This is a huge potential for India for putting a solar power plant. However, India's target is to put 175 gigawatt by 2020 from the renewable sources. Out of that, 100 gigawatt is from the solar, 60 gigawatt from the wind, 10 gigawatt from the hydro, and 10 gigawatt from the biomass and 5 gigawatt from the hydro. Out of that 100 gigawatt, as I told, 34 gigawatt is already commissioned, 46 gigawatt is in a pipeline. So coming to the, it's just I'm not going in detail of how the solar system is installed and the entire. Probably you might have some few understanding of it, but I'm not going in details. Just telling that the solar system can be installed on the ground, it can be installed on the roof, or it can be installed on a floating system. So ground mounted system will be a tracker or a bifacial, a dual axis tracker, single axis tracker, or a fixed tilt. Rooftop we can put on any of the industries, big industries, where manufacturing industries, we can put it over a rooftop and it will be consumed in the same factory. And floating is a very upcoming market where it can be installed over a lake or a dam. As Rohit told here, like we being a construction engineer, we will be doing civil and mechanical and electrical works. So yes, it is very true that we have to be a part of, we have to do some civil works as well, we have to do mechanical works as well, and in any of the projects. And this photos of the ground mounted system is from the Charanka Solar Park, and I was a part of that project. And this switchyard, what you are showing, is 11 by 66 kV switchyard, and it was entire construction was I was a team of the switchyard part. So I was doing a civil part as well, from the marking to the excavation, then backfilling, and then equipment directions. All means you have a lot of opportunity to do all these works there, and you will be dealing with the civil, mechanical, electrical works. So module technology, I'm not going in detail of the module technology, but yes, as we have a thin-film, polycrystalline and monocrystalline modules. And as of now, with the preferred one is monocrystalline. The industry is completely shifted from polycrystalline to the monocrystalline because of the efficiency. And mono PERC modules we are generally using this, since we have, you can say, we in a PERC module, we generally have a metal layer here, which the solar rays get reflected and give more generations. Bifacial module, again, it will be used in a tracker systems, where it can be use direct radiation from the solar and a deferred radiation from the ground or the other reflecting parts there. So in bifacial module, we are also using in a tracker, where the power generation is more compared to the mono PERC. Coming to the ESS market, energy storage market is a new upcoming market here, and India is expecting to add around 80 to 85 gigawatt hour of battery energy storage systems, mostly for the energy shift application or EV market as well. And I will tell you what is the energy shift, and I'll brief you more in detail about the use of and applications of the energy storage systems. And by 2040, India can add around 350 plus gigawatt hour in our of battery energy storage systems. Coming to the technologies, probably you might have few informations about the energy storage. Lithium ion is going to be to lead the market here. It's expected that 50% of the applications will be from the lithium ion. As of now, lead acid batteries and flywheels are more used, but since the lithium ion prices are going down, we entire energy is shifting to the lithium ion, considering the TOD life cycles and then other technical stuff for the lithium ion batteries. I just give you a brief of the battery energy storage system. It's a battery energy storage comes in a two ways. One is a containerized air cooled system or a liquid cooled system. So it's the photos here is a containerized air cooled system where it will be placed in a 10 feet, 40 feet or 20 feet container. We have battery cells which will be get stacked over a rack. Battery cells basically form the modules, and then again it gets stacked over a rack. So we have multiple racks installed in the 40 feet containers. The output of this battery will come into a PCS, power conditioning unit, and it will get a step up with using a transformer here, and then it will go to the grid, or it will may get connected to the your existing solar farm or any solar farm or with the other applications. Inside the battery system, we have HVAC firefighting system as well installed in the 40 feet container. If you're going for a liquid cooled system, we will not, it will be just small racks, and it will be just a small rack of 372 kilowatt or capacity, and we do not have any HVAC or any firefighting protection systems. It will be here the capacity will be around 4 to 5 megawatt hour of a single 40 feet container, but it is just a 372 kilowatt of one rack. Okay, and we will be having liquid cooled, like water and glycol coolant will be flowing through the racks and keep the liquid cooled cooled. So you do not need any HVAC system, and then hence you have a less auxiliary consumptions compared to the your air cooled system. So that's the major difference compared to the safety as well. So safety, it is more safer, since any incident happen, you are putting entire 4 megawatt capacity on a stake, whereas in a liquid cooled system, once any incident happen, it will be just burning out your one unit. I'll show you one layout of both the systems. It's just for one of the project where, is it visible, my layout?
The battery storage system liquid cooled is shown.
No, layout nahi aaya abhi. Layout is not there.
Okay. Yeah.
And now it is there.
So this is a concept design for a liquid cooled system where we have a small battery racks. It's not a 40 feet container solutions. We have a small racks. This for a 50 megawatt hour battery energy storage system. This racks will goes and output of this system will go and connected with the power conditioning system, and then we have a twin skids. So as Rohit was telling that we have to keep our basics electrical concept in line whenever you are dealing with any of the projects, and since you have to deal with all these equipments when you are sizing a system, or you are discussing with the vendor, or you are discussing with the customer, so you must have to aware of at least a basic that is very needed to understand to understand this entire systems. So we have a complete MV skid is like we have a containerized transformer and ST panel, and it will be go and output of this twin skid will go and get connected with your switchyard here. This is a replica of all the systems. So we have here again a switch room, and then we have a switchyard go and get connected here, and it will go evacuated to the grid system, or will get evacuated to the grid. And similarly for you got my screen for
Yes.
Battery energy storage system.
Yeah.
Air cooled.
This is for the air cooled. This is the layout for the air cooled system, where we are putting a entire 40 feet container, and the system will go and connect it here with the ST panel, and power will go to the grid. So that's the major difference. We are putting a 40 feet container. So if any incident happened, there would be a chance that entire 4 or 5 megawatt hour system will blown away. But so layer liquid cooled system is more you can say more safer than a 40-foot battery air cooled system. Coming back to the presentation again. So what is the functional requirement of the energy storage system? It can be used for energy shift application. Energy shift applications means the battery will charge in the morning, or if there is any curtailed power during the peak time, it will be get stored in the battery energy storage system, and it will get injected to the grid when there is a demand in the evening time, you can say. And as I was telling that wind is highly unpredictable, but putting along with the battery energy storage system is make the system highly viable. Suppose there is a huge generation from the wind, it will get stored in the battery energy storage system, and the stored power can be used whenever it is required. So this is one of the applications. Second application is for the energy storage system, is for the power applications when we need a power for a 10-minute time or a 5-minute time or for a millisecond as well. So it's like for arbitrage. Suppose we have a high tariffs in particular durations, we can store the power, and that stored power can be fed in when there is a higher tariff compared to the other normal tariff timing. Spinning reserve, we can use it for a spinning reserve power applications when we have to keep the power for a 10 or 5-minute time. We use for a frequency regulation and voltage regulations energy storage system. Peak saving, you can say during the peak time when since there is a huge penetration is happening during the daytime from the solar, we can save, and we do not have that much of load. So what we have to do, we have to shut down the inverter sometime, and in that case there will be loss of power. Instead of doing that, what we are thinking, we are integrating the solar system along with the battery energy storage system, and that whenever there is a power and demand is less, it can be stored in a battery energy storage system, and it will be given to the grid during the evening time or whenever it is required. So these are the major applications in the battery energy storage systems. Coming to the hybrid system, what is a hybrid system? Hybrid means we have an energy mix of solar, wind, battery, solar, wind, or DG. So as I was telling that I'm dealing with the projects globally, there are a lot of islands which are completely running on a DG sets, and some of the financial institutes is coming up and funding that islands to install solar or wind and battery energy storage system to cut down their carbon emissions. So there are a lot of opportunities coming up where hybrid opportunities coming up where you can put this energy mix system. So you will have a solar, you will have wind, you can integrate with the existing DG set, and we have a battery energy storage system which will be sized as per the requirement of the grid and load requirement. So this, to design such system, we need complete understanding of the electrical system and electrical system what you are studying as of now, and that will be really going to help you to design a correct and size it correctly and precisely. So coming to the top developers, so what these are the major developers. Developer means who is coming up and putting the firms in renewable energy. There are tenders which is coming as a developer, means the company is going to invest in the project and they are going to sell the tariff to the government or to the discoms. There is a particular power purchase agreement for 25 years, since the life of solar power is 25 years, and they're going to sign long-term or short-term PPA, power purchase agreement, with the government, and they sell the power. Probably you might have reading in the news article that the solar tariff has gone to 1 rupee 99 paise. It means these developer is going to put the solar farm and going to sell the power for 25 years at 1 rupee 99 paise. But this tariff keeps fluctuating in every bits. But I'm saying that the minimum which solar tariff has reached is 1 rupee 99 paise. When I have joined this industry, the tariff was rupees 15 rupees for 1 unit. Right now, the industry, the solar tariff has gone to 1-2 rupees around. So this is the difference in last 10 years in the renewable energy. So if you see the names, Adani, you might have heard, Adani is the one of the largest developer. They are doing the self EPC as well. And then we have a Renew Power. Renew Power again is a developer, and they are doing the self EPC. Adani recently have bought the SoftBank Energy, and all the acquisition is over. NTPC is another developer. Tata Power, Acme, Greenco. These are all the top developer. You can always target these companies, and they are the very active player in India. Coming to the EPC side, Sterling and Wilson is one of the large. EPC means engineering, procurement, and construction, where this industry I belongs to. Even L&T was also EPC company. Sterling and Wilson is also an EPC company. EPC company, their role and responsibility is to completely design the system, procure the system, and construct. Suppose this developer has bidded for the tariff, they will come up with their own RFQ and search for the EPC players, and we as a EPC player design the system and construct a project for them. So Sterling and Wilson is one of the EPC company, largest EPC company in the solar industry. Then Tata Power, L&T, KEC, BHEL is an EPC. Mahindra Sustain is in the EPC, solar EPC. Siemens, Vikram Solar. These are the major company you can see in the in the EPC business. What an EPC do, as I told that from its inception to its completion, is the EPC role is to construct the power plant and maintain the power plant. So the first and foremost is to get the details of the site for all the required parameters for the designing the systems. Then we go into the project executions. Then we size if there is any addition of the energy storage system, we size and design the energy storage requirement for that. Then we close all the commercials considerations for that. What will be the total cost of the projects? What will be the operation maintenance cost of the project? And then we give a performance guarantee for the system performance, and how the system will perform. For the solar, there is the performance parameter called PR guarantee. We generally give a performance ratio guarantee, but that solar is going to perform at 80 to 85% of the PR. Then our work, once the project get commissioned, we hand it over and we take a O&M service from the customer, where you have to operate and maintain the power plant for next 10 years, 15 years, or 25 years. And our design engineering team will do all this technical stuff for preparing the SLD layout, Homer and PVSys reports, SCADA and architectural designing and all. So what will be your role responsibility if suppose you are opting for a EPC companies, you will be, EPC company will have a different verticals. Vertical means they have a design team, they have a project team, they have a project management office team, procurement team, and sales team. So suppose you are in a design team, then you will be completely looking after the design, engineering, AC, DC, mechanical, civil engineering design, and the SCADA system design systems. Like Rohit is completely in a design engineering consulting firm. So his role and responsibility is only on a design engineering there. Project team, as I told, means project team is going to execute the project once the design is completely prepared and gone to the site. The site person at site is going to execute the system system as per the design. If you are in a project management team, you are going to manage the project. Project will be like you are going to give monitor it, how the project is going to you are going to prepare a daily progress reports. You are going to see how what is the requirement at the site, and you are managing all the things sitting in a headquarter and putting all the resources in line. Basically, if you are in procurement team, you are going to procure the materials required for the projects, and either it will be a transformer, modules, inverters. And if you're a sales team, you are going to bid the tenders, estimate the tenders. So this is all a role and responsibility you are going to take in if you are going in an EPC company. And all these functions we will need your basic engineering requirements, since you have to deal with the equipments, you have to deal with the customer, you have to deal with the vendors. So if you're buying a transformer, you're buying an inverter, you're buying a inverter, you should be aware of that. What inverter, what are the IGBT requirements, how it functions, so what MPPT requirements, so everything you should be at least aware of. I'm not telling that you have to go and detail the sizing. At least, yes, the design team is going to do the system designing and engineering works in detail, but if you are in other functional teams, you at least need a basic to keep your dialogue clear with your requirements. So this is what you're going to do in a EPC company. Some of the reference I must, if you are looking for a renewable industry, you must go through some of the reports of Bridge to India, Markham India, JMK reports. You can go and visit few of the Ministry of New and Renewable Energy website. You can see since a lot of tenders and opportunities and policies are coming through these websites. So I must recommend you guys to refer these websites and refers few of the reports of Bridge to India and Markham India, so that you will be aware of the industries. And if you are opting for the renewable energy business or industry. Yes, thank you, sir.
Thank you, Pratik. Thank you very much.
Sir, I would
Students,
like to, before taking Q&A, I would like to say something, sir. I would like to add on this.
yes, please.
Actually, just I wanted to share my personal experience actually when we were in college. During 7th semester or during 4th year, at the start of 8th semester, our technical placement team is there. So, and as well as our electrical sciences team is there, electrical sciences teachers are there. They were very much in contact with us, with all of us. They were very much open to our questions and our things related to placement. We are working and hard, and we are studying hard just for the placement. Basically, many of us are going to have higher studies. Many of us will be working after placements. So let me assure you that our teachers are there, our placement cell people are there. They will help you out in every part of there. So you need not worry. Coming from us, I can assure you that whoever is coming to speak in coming days, or whoever have spoken already, they would have said. And if not, they have not mentioned this point. I would like to assure you that if you are there, our teachers are also there, our college is also there. It's just not that I'm saying for the sake of it, but that is from my personal experience. I know everyone there, and don't worry for that. Just do your part and work. Everything will work out. So thank you,
That's more
everyone.
important.
Yes, sir.
Doing their part is more important.
Yes, sir. Yes, sir. Thank you, everyone, once again.
Thank you. You may have any questions, please put it in the chat box, or if you want to speak also, we will unmute. Raise your hands and we will unmute.
Yeah, students, if you have any questions, please post in the chat, or you can raise your hand and we can unmute it. Yes, Pratik, actually, I have one question. Can you highlight the scope of EV in the coming years? Because there are few industries coming to our campus recruiting students. How the students need to prepare from third year or final year to get into the EV sector? Like if you take Ether, I think couple of years they actually visited.
Yeah.
And yeah, similar to that type of company, what are the things they need to concentrate?
Yeah, so EV is going to be a very huge market. So government is pushing the EV market and converting all this uh, 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 vehicles to the EV, and I feel that they can prepare and look on the lithium ion and technologies, where they can first they should focus on the lithium ion technologies, how that works. Secondly, that is the basic one. And secondly, how the market is going to be opened up for the EV. As of now, like it's like they are going to put some EV charging stations in every 3 kilometers on a highway. That was the plan, but still it's like keep on evolving. Like there is a chances that it will be a 40 feet or 50 feet charging stations, and it will be movable. So it's like a movable petrol pump, you can say, and on a highway where you can go and plug in your anywhere it can stop, and you can go and plug in your EV vehicles and charge your EV vehicles. Secondly, there is a market where you have to go and replace your completely battery of your car. Means it's like go plug and play system. You go to your to the charging stations. It will be a charged battery. An uncharged battery
battery
will be
swapping
taken out.
system.
Yes, it will be taken out, and a charged battery will be again placed in your vehicle. So such things are keep on evolving. So I feel that I suggest the students here that they should keep reading all these articles, how the market is evolving, and that will be really going to help and crack the interviews and while discussing with the interviewers.
Yes, correct. And
Secondly,
one
technical aspect is completely different. Yes, they should aware of the how lithium ion operates and what will be the charging discharging cycle, depth of discharge. So there is not much of sizing involved in that. Sizing is more involved in the power segments, but in EV we do not much requirement of the sizing of the systems. So at least they should be aware of the technologies. Yes.
exactly. And like if you take in recent days, there is actually much focus towards aluminum-based battery instead
Yeah.
of concentrating on the lithium, because India is pushing towards the aluminum-based material batteries.
Yeah.
Since we need to heavily depend on China for lithium.
Yes.
Is there any scope for that actually in India, or is there something
I
will
feel
have
that more than aluminum, hydrogen is more pushed. Since it is abundantly available, so hydrogen is going to be a next big market compared to the aluminum. So lithium ion is the as of now lithium ion is trending in the market since the lithium ion price is going very down. Right now we are doing a project at if you specifically ask for the battery price, it is below 100 now for a lithium ion per kilowatt hour. So as of now, considering the price factor, lithium ion is there, and with the new upcoming technologies, hydrogen will be the next big market. So we need to focus on hydrogen more on that. Yeah.
yes. Is there any other questions from student side?
Over and above, I just like to add here in the specialty means coming to the core sectors. I feel that if you have been in a core sector, you are going to execute a project where you can proudly come and say that, okay, I was a part of this project. So like how Rohit was telling that I was a part of Delhi Metro or a Hyderabad Metro or a Bangalore Metro. Similarly, I have done a projects where it was Asia's largest solar park or ultra mega solar park of Reva, which has inaugurated. So whenever you can you can in a society, at least you have something that, okay, this is what I have done in this, and I was part of this project. So this is one of the specialty I feel proud in that in being in a core company. So this I feel that it will be really motivating factor here. Yes.
Yes, that type of a small scale project, they need to choose in the final year itself, and they need to work on it. So they may get some basic understandings.
Yeah.
Yes, sir, definitely, sir. What I feel, sir, we have come across many papers also in metro systems. Also, there are many things related to, like if you want to study the system, there are papers that define that even in for cables, there are systems are there, how we can maximize the cable utilization, how we can minimize the harmonics, how we can include various hybrid energy storage systems are also there. So there are many final year or even IEEE papers being presented right now currently. Whenever we also study and we also go through those papers if we need it. So there are many upcoming things that can be included in our final year projects related to these industries. And in coming few years, metro is on a boom actually. If I say metro systems, in each and every city, we are seeing that metro system is going to come. So if you are if you are interested in these systems, you can go on internet and have many. There are many materials available. You can study those things. You can prepare your final year, even final year projects people are doing, and they are going out and studying those systems. Internships they are doing in those, and after that they are going not in India, even in outside also there is a very much demand for these kind of work. So this industry is on the boom, and if you are really interested, all the in India at least I can say that in another 10 years or 15 years, all the major cities will have this system. And one more additional thing I would like to say, like we discussed regarding hydrogen, there are hydrogen based electrical coaches, train running locomotives are being developed in Europe. Those are going to come in India actually, one if in future maybe. But right now, hydrogen based, hydrogen fueled electrical locomotives are there that has been developed in Europe. So that is a very interesting thing. So yes, many new things are coming up. We have to be just look into that. And if you are really interested, you can go in from final year itself. You can go it, and you can do research. Even research is available in these fields actually. So all the aspects are there. If you want to join industry, it is there. If you want to do higher studies, it is there. If you want to research, it is there. So all the aspects are there. Just we have to choose from that.
How about venturing entrepreneurship in such fields?
Sir,
Or being a
entrepreneurship,
startup?
yes, sir. Being in a startup, I would like to say that it will be like providing services or including some new products like renewable energy products or some technologies that would provide your services for studying the systems. Like I told about harmonics, there are many small companies we are who are coming out and saying that yes, we are being expert in this field. And in those what I have seen, sir, many simulations or softwares which we deal, and many people which we are dealing with, they are just fresh out from the college, like 1 year or 2 year experience they are having, and they are working on these softwares, many software simulations, sir. Electromagnetic induction, electromagnetic compatibility, these harmonic study, power system analysis, lightning protection, surge arresters, all those things are being done by freshers only, sir. Means I have seen many people who are fresh out of the college and have discussed that they have been recruited and they are being working on that. So that is also a very good thing. So from here also you can start up. Many people are starting on their own. They are doing freelancing also after studying or after coming into the understanding these things. They are giving their services. So that is also one aspect what people are developing now, sir, rather than working somewhere else like that.
So that is in general on which area technically we are good at. Is it in IT or embedded or core?
Yes,
The
sir.
startup culture is the same. So here also it is, we have some
Yes, sir.
awareness. Yes.
Yes, sir. Yes, sir.
Yeah, Pratik.
I think Sridhar sir is asking something.
Yeah, Pratik. Sridhar sir here.
Yes, sir.
Yeah, very heartening to know that you are part of certain projects that we study, especially the Charanka project and all. I have 2 questions to you. Okay.
Yes, sir.
Yeah, in fact, 3 questions. First question is, what about the battery integrated system with respect to the grid, right? PV tied with grid, especially, right? Pros and cons of that. That is first question. Okay. Second question is about the floating solar plant. In fact, maybe your same batch or maybe your junior, I think, Karthik Narayan, he is having a company on that. He's tying up with the EDAC.
I was.
Company.
Yes, Karthik was my junior, and I have interacted AdTech. AdTech is the company name, and he's based out in Kerala.
Third important question is, third important question is, especially it may comply to both of you, right? Regarding the research and development aspects, though we say a lot about the traction BLDC drives with respect to the traction as well the PV system, right? Take for example the inverters, right?
Yeah.
Even the inverter, what we rely upon the grid inverter is not much of the indigenous system.
Okay.
Okay.
Yes.
Yeah. Why it is not happening, or companies are satisfied with getting from outside and plug and play? Likewise, why it is not that much happening with respect to R&D in both sectors? Okay.
Yes. So I will just
the
quickly
questions.
answer your question, sir. First thing you have asked that what is the pros and cons of the impact of integrating a PV system with the grid and how the energy storage system
Battery, especially with battery. Yes.
Battery energy storage system will helps in that.
Yes.
So probably you might have aware that as I have shown in my presentation that in a PV system is keep on adding up in the with our grids, and the more the generation from the solar in more the generation of solar is happening during the daytime during the 12 p.m. to 2 p.m. And that time once the entire solar system of 34 gigawatt and which is going to and further is going to connect more in future is running at on a peak, we do not have much of demand from and we do not have much of demand. What will happen, it will disturb our grid become unstable, and there the energy storage comes in play. So what we are doing as of now, we are coupling the battery energy storage system with the PV system. Either it will be a AC coupled system or a DC coupled system. DC coupled, if we are talking about a DC coupled system, the DC component of the battery will go and connect with the same PV inverters. But if you're talking about the AC coupled system, there will be a separate PCS for the battery, and both the inverter output and the PCS output will go and connect with the ST panel separately in another AC side. So that is different between the DC and AC coupled system, where the battery role is to here the cut whatever the power excess power generating in the during the daytime, it will be get stored in the battery, and it will be dispatched when the solar shutdowns. Shutdowns means at 5 p.m. or 6 p.m. once the solar shuts, we dispatch the battery energy storage power stored in the battery. So this is one point. Second, you have asked what will be the impact of a battery with the grid. There are a few projects where we have just put a battery solutions along with the substations, near to the substations, and the role of the battery is to voltage and for the voltage and frequency regulation only. Means it will keep our voltage and the frequency in the required limits. The battery energy storage role for that and design for that. So this is one thing. Second, you have asked on what was your second question, sir? You have asked on a indigenous why we are not going with the indigenous batteries.
Yes.
Sorry, PCS. So the thing is like inverter and the PCS. Yes, we most of the our vendors are from the overseas companies, and the fact is that they are more performing. Ultimately, we are designing a system for 25 years, and we are giving a guarantee to the customers. So what we have to do, we have to go only with the reliable solutions. As of now, all the companies like you can say inverter company like Sungro, ABB, Hitachi, so
SMA,
SMA, and these companies put lot of funds for the R&D, research and development, and they keep on evolving their technologies, which is not happening in India as such. Few companies are going up, but still they need some government posts or some government finance to put in research and development funds. Even the companies like L&T has sold their business segment of switch gears to the I think Schneider, I remember. Why? Because they do not want to fund more on the R&D, and that's really required. Means if any product business needs funds for research and development, they have to keep involving their technologies, otherwise they will be out of the market. And since the competition is going in that way, if you look at the module technologies, when I was there in 2011, when the solar starts booming, that time we are using a module of 150 watt peak. Right now, we have a module of 600 watt peak and plus. And that's the reason that's what I told. That means we have to focus on the research and development, and companies are not pushing, Indian company at least, and not pushing for means giving a fund for the research and development. However, overseas companies, as I told, Schneider, ABB, Hitachi, SMA, they are putting abundant of 20 or 30% of the revenue on the research and development. Floating technology is an upcoming market. There are a lot of floating vendors as of now came to India. I am in touch with the Karthik as well. His company name is Adtech Technologies, and they are doing quite well. Even we have L&T has done one project of 4 megawatt in Tirupati, where they have procured solar floaters from the Adtech. So, floating is going to be a next big market. Even floating, we are proposing for in hybrid projects for the islands where the land is not available, and we are going to put the solar plant over over a lagoons where there is not much waves. So this is the concept we are developing. There are a lot of tenders coming in the Maldives as well for such hybrid opportunities where floating solar will be there on a lagoons. We have battery energy storage system over a land, and their existing DG systems. So there are a lot of such hybrid opportunities coming for islands. There are hybrid opportunities for the mines coming up. And yes, for the utility scale project, we are integrating solar, wind, and battery system in utility scale.
Yes, Pratik. Yes, Pratik.
Sir, I would
Thank
like
you.
to add something there. Like you asked regarding inverter technology and battery technologies, what are the things? Okay, the main issue, one of the issues which we are seeing in our metro system is there many things are proprietary actually. They are being developed in-house by those like ABB, Alstom, Siemens. All they are having their proprietary softwares and proprietary products, which they are not going to disclose to outside anywhere. Even though we are doing in India, they are being taken from outside only. So until unless we develop indigenously, I don't think there will be very much help those companies are going to do, because they are having their proprietorship and they will not disclose those technology to anywhere. So it is one of the, that is also one of the issues. Because of that,
Yes,
we are
Lohit,
not
yes.
developing in India, sir. And additionally, one question is there: how can we join these metro organizations? So these metro organizations, they conduct their own exams actually. Delhi Metro conducts their own exam. Bangalore, everyone conducts their own exam, and additionally, they take through GATE also. On GATE score, if you are giving, they take through those also. So you have to look out for those examination dates. They are available on their websites, respective websites. So you can check out those regularly, and from there you can fill the application and you can give exams actually. So that is the process. Apart from that, if you are having some experience, based on experience also they take, but generally they don't consider the experience of private sector. If you are in Indian Railways or some other organization related to metros, you can go from one metro to another metro. But if you are a fresher, you have to be giving exams, and from there you can enter the organization. So Ratnasam, I think any question, anything else is there, or we can wrap up?
There are three things were there.
Yes, sir.
How to join these metro organizations? Is there any guideline?
Yes, sir. That's what I was just speaking about.
Yeah.
That
after that, we didn't have any questions.
Okay, sir. Okay, that I have said that they have to look out their websites for examinations and all those things, or they can enter through GATE also. So these two things they have to be updated on. So
Students, any more questions? If you want, we can unmute also. Naramurthy sir. I think there is some power cut in college. So, okay. Okay, so thank you, Rohit and Pratik, for joining and giving complete awareness about the organization and the experiences what you had. Very nice of you with the videos and things. You have made it very well.
Thank you, sir.
Thank you very much. Thank you for joining. Students, you may wait for 2-3 minutes for ma'am to post the attendance link. And also we have tomorrow session by the same 9:30. Join and get benefited. In case of any help you require, you reach out to us through WhatsApp and in the groups. Thank you. Thank you once again.
Thank you, everyone.
Thanks, sir. And if they have any queries or they want any information from us, they can directly contact me on a LinkedIn.
We'll share the
details. And you can share our details to them.
Yes.
Sir. Okay. Thank you, everybody. Stay safe,
thank you, everyone.
Thank you.
Stay safe and prepare well for your upcoming placements.
Yes, all the best to everyone.
All the best for that. And enjoy your 7th and 8th semesters to the fullest. You are going to enter in the next phase of your life where you have been given some responsibilities as well. So thank you, everyone.
Already started.
Already.
Yes. Okay.
Thank you.
Thank you, everyone.
Thank you. Ma'am, is that link working now properly? Students wait and you can update.
Sorry. Correct.
Students, please check the form which has been posted now. Is it working? And all those who are here right now can enter once again, if you have already entered also, because it has been edited by some of the persons. We are unable to have that link. One of you please confirm that it is working. I have tested from my side.
Yes, sir, it's working. Myself, Selva Kumar.
Okay, Silva, super. Okay, nice. So let everyone who are available right now, please fill it in maximum 3 or 4 minutes, and then we will stop the Zoom and stop accepting the responses also. Silva, நீங்க இது பண்ண முடியுதா அது?
நான் fill பண்ண முடியுது சார்.
எடிட் பண்ண முடியுதா என்ன? ரெஸ்பான்சஸ் பார்க்க முடியுதா?
இல்ல. Only
Okay. Okay, it is live on YouTube. We'll stop.